here in our option, first two options, you see odd and here even. So we proceed taking both the possibilities. I mean, suppose y, the function is our y, and it suppose it to be fx here, and both fx, and suppose it is even, suppose it is odd. I am proceeding taking both the possibilities. So in case of even function, it will be fx equals to f minus x. Okay, and here in case of odd function, it will be fx equals to f minus x. Okay, now if we put x equals to 0, then it will be f0 equals to f0. So you are not getting anything. But here on the other side, if you put f0 both sides at the place of x, put x equals to 0, then you have, and from this we have f0 equals to 0. So we got something. Okay, and here in the question this you see the same. Okay, now we differentiate. Okay, now we differentiate this function, and here this function. On differentiation, you have f dash x equals to minus f dash minus x, and in this side we have f dash x equals to f dash minus x. Okay, now put again x equals to 0 both sides, then here we have f dash 0 equals to 0, and this is an important relation. And if you put x equals to 0, then it will be f dash 0 equals to f dash 0. So you are not getting anything. Okay, anything important. Okay, now, so what did we learn so far? We learned that if fx were an even function, then f dash 0 should be 0. Okay, and now if you see this one and this one, okay, then you will notice that this thing is nothing but this thing, f dash x equals to x square plus fx square plus 1. Okay, now if we calculate f dash 0, then this will be 0, here will be f0 square plus 1, and here from this, you see this relation, from this is 0. So 0 plus 0 plus 1 is 1. So we got f dash 0 equals to 1. And if you compare here with this box, you see, with this box here, it is f dash 0 equals to 0. This ensures that y equals to fx is not an even function. So what did we discuss so far? Its conclusion is that y equals to fx is not an even function. Okay, I think it is clear to you. So our option B is wrong. It is not our option. So the work pertaining to you see on the screen. Now I erase those parts because they are of no use now. Okay, so I erase this part, one part. Okay, okay. Now now I proceed assuming it to be odd, so it should satisfy other criteria. I have checked just for a point. That point is 0, x equals to 0. But you know, on a function it is infinite number of points. Okay, so now I differentiate. I take this relation that is given in the question. You see this one and this relation, and you see this one. I keep it in a box. Okay, you see the blue box and this relation that is given in the question. From these two I write the same equation. You see here, f dash x equals to x square plus fx square plus 1. I understand that you know these things. Okay, very simple. Now integrate both sides with respect to x and taking the limits, the lower limit 0 and the upper limit x. And if you do, then you have fx equals to x cube by 3 plus fx square. Here will be dx 0 to x, because I have already told that you have to take the limit from 0 to x, and plus x, and here a c, the constant of integration. And now see the initial condition given in the question. You see here, and this thing is same. Okay, both are same. You see the blue box. Okay, both are same. So here I put x equals to 0 both sides, then this will be f0, here will be 0, and this will be 0 fx dx 0, and here c 0. And you see in the question it is 0. It is 0. From this we have c equals to 0. Okay, so I now erase the lower parts, because the lower part is just to show you the value of c. It is 0. And here I now erase c also because it is 0. Okay, now see here I have assumed fx to be an odd function. For that you see here, I show you. You see here, this is an odd function. Okay, this is an odd function. Okay, and here it remains the middle term, this term. Suppose it is gx. If I show this gx is an odd function, then you know sum of odd functions is an odd function. So now the work remains, now it remains to prove that gx is an odd function. Okay, so I go for this gx and I write here that gx 0 to x fx square dx, and you know this can be written as 0 to x f t square dt. Okay, now let us find g minus x. Let us work for g minus x. Okay, so this will be 0 to minus x ft square dt. Okay, now let us change the limit. Okay, now let us change the limit. I do work for that here. Let t equals to minus y. Okay, then dt will be minus dy, and the lower limit y equals to minus t, and lower limit you see is 0, so minus 0 is 0, and the upper limit y equals to minus t, and minus, and t is minus x, you see as upper limit, and this will be x. So this integration can be now this integration will be 0 to x f minus t, and here will be minus dt, so for that minus I write here. Okay, now and also don't forget to write here a square. Okay, so now I erase this thing. This was for just to write the limits, lower limit and the upper limit. Now see this formula, not formula, this is an equation, sorry, see, sorry, once again, okay, you see this one, from this I can write ft equals to minus of f minus t, and if you take a square both sides, then this will be ft square equals to f minus t square. Okay, so from this, using this I can write the next step as 0 to x ft square, and here dt. Now see these two, see this one, okay, and this one, both are same, and that equals to gx. Okay, so the next step will be this equals to minus gx. So what did we get? I show you in green. See this, g minus x comes out to be minus gx. Okay, this means that gx is an odd function. So this is an odd function, and you know x is already an odd function, this is an odd function, so sum of odd functions is an odd function. So option A is correct option. Okay, so I now erase the screen because we have worked for odd function and even function. Now it is time to work for, you see in the next option, you see minimum and maximum. Okay, so now we have to work for these two terms, minimum and maximum. And I want to show you that in the question there is nothing mentioned like that, R to R. This means that this ensures that our yx is a real function, but it is not mentioned in the question. Okay, I think that suppose yx may be of this type, fx, or yx may be of this type, gx plus ihx. Okay, in that case yx will be a complex function, but here you see the options here, minimum, maximum. This means that we have to compare, and you know comparison is not allowed in complex numbers. I mean, you cannot say that 2 plus iota is greater than 1 plus iota. Order is not defined in complex numbers, So even when it is not mentioned in the question function R to R, you have to assume it to be a real function. Okay, so now I go for this one, very easy. You see, as I said that yx is a real function. Here I write yx is a real function. Okay, a real function. Okay, so a square of any real number is always non-negative. This means that minimum of yx will be 0. Okay, and you see here, this is the relation. It is obviously 0 at x equals to 0. Okay, so this confirms that at x equals to 0, this function, from here one can write one more step, and that step is this one, equals to 0. Okay, and a square of any real number is non-negative. This means that this ensures that the minimum value of a square of any real number is 0, and which you see on the screen. So it means that yx square has a local minimum at 0, because here at 0 means you have to put x equals to 0, and you see I have already proved that it is 0, and that is the minimum. A square of any real number cannot be less than 0. So option C is our correct option. So what did we get so far? We get that two options are correct, A and C. Actually, this question is of MSQ. It means that multiple select question. In such type of questions, you have to choose. There may be more than one options correct. Okay, you have to choose all those correct options. If you are not choosing all questions, all correct options, then you will not get any mark. And one more thing, there is no negative marking in such type of question. Okay, so we are done.